This is the last lesson in Unit 3, writing function rules. Notice what I said was the first learning target. I can identify the pattern to get from the domain to the range, and then I can use that pattern to write a function rule. So in this lesson, we're going to kind of work backwards from what we've done so far. Instead of giving you the function rule and having you create a table or find a value or find a range or whatever, instead of using that function rule, we are going to find the function rule or write the function rule. Okay, find and write actually. In the following tables, identify the pattern that gets you from the domain to the range. Then use that pattern to write a function rule. So a lot of people in the past have done something like this. They say, oh, it's just counting by twos. Oh, it's just counting by twos. So the pattern is just counting by twos. But that's only a pattern between the domains. I want to know, how do I get from the domain to the range? So I'm going to look at my first one. How do I get from 0 to 3? Well, I would add 3. Well, that's true, but it has to work for every single one. The same thing of adding 3 needs to work for all the domains in the table. So 2 plus 3, yes, it gives me 5. 4 plus 3, yes, it gives me 7. 6 plus 3 gives me 9. That's my pattern. So the pattern is add 3 to x. So now the function rule is literally just, well, here we go. Back up a second. Add 3 to x to get to f of x. So what that means, add 3, so 3 plus x to get to is another way of saying equals f of x. So once you establish the pattern, you've basically gotten the function rule, and there is your function rule. Okay, if you had written it like this, it would have been fine. F of x equals x plus 3. So you're taking whatever x is and you're adding 3 to it to get to the y value. Okay? Number 2, 0 to 0. Well, I add 0 to that. Okay? 1 plus 0, is not negative 4, so that doesn't work. 0 to 0, I could multiply by 0. 1 times 0, well, that's also 0. That's not going to work. So instead of starting with 0, 0, I might start with 1 and negative 4. How do I get from 1 to negative 4? Well, 1 minus 5. 1 minus 5 gives me negative 4. 2 minus 5, nope, that's not negative 8. But another way to get from 1 to negative 4 would be to multiply by negative 4. 1 times negative 4 gets me to negative 4. 2 times negative 4 is negative 8. Negative 3 times negative 4 is positive. That's it. Pattern is multiply x by negative 4. And by the way, 0 times negative 4 is still 0. So the function rule is y equals negative 4 times your x value. If you would have put f of x, that would have been fine too. Next one, how do I get from negative 2 to negative 7? I could subtract 5. 4 minus 5 gets me negative 1. 6 minus 5 is 1. 9 minus, there it is. Subtract 5 from x. So my function rule would be f of x equals x minus 5. I take whatever x is and subtract 5. The last one is definitely tricky. Okay? How do I get from 0 to 15? I add 15. 5 plus 15 does not get me 10 though, so it doesn't work. How do I get from 5 to 10? I could add 5, but that doesn't work here. But hopefully what you're seeing, maybe you see it, I don't know. If you add these two up, don't they all add up to 15? 0 plus 15 is 15. 5 plus 10 is 15. 10 plus 5 is 15. 14 plus 1 is 15. So another way of saying that is x plus f of x equals 15. And yet another way of writing that is x plus y equals 15. Now, back in the beginning of the year, we talked about solving an equation for when you have two variables. Well, I have that situation here. I'm trying to write a function rule for y, so I want to get y by itself. To do that, I'm going to subtract x. So y equals 15 minus x, right? Hopefully you remember doing that. They were called formulas or literal equations. And let's see if that works here. So this, I get this by doing 15 minus the x value. So 15 minus 0 is 15. Good. 15 minus 5 gives me 10. 15 minus 10 gives me 5. 15 minus 14 gives me 1. It worked. So what I did was I subtracted x from 15. This one was tricky. I'm not going to do anything like that to you on a test, but it's good to see the relationship between the domain and the range. Even if it's not just adding, multiplying, subtracting, or dividing, the relationship was that they together added up to 15. So that right there is my function rule. Okay, in problem number 4, so in this one right here, what is f of 20? I want you to answer that question. Okay? I'm going to see if you remember how to evaluate a function. Okay? That's a review question right there, using what we did here. Okay? What is the x value when f of x equals 3? Again, we're talking up here. So f of x is like y, right? So I'm asking you, what's the x value when y equals 3? Well, I have an equation here. I can put 3 in for y. And I can solve that for x. Okay, so subtract 15. So I get negative 12 equals negative x. Divide by negative 1. X equals 12. I used the function rule to make conclusions and to figure out other pieces of information. Okay? Applications or word problems. A lot of people get freaked out when they see these, but these really aren't that bad. A cup of frozen yogurt at Yo-Yo costs 49 cents per ounce. Write a function rule to determine the final cost, and I want you to call the final cost C of n, of buying n ounces. So basically what I'm saying here is C of n is standing for the final cost. N is standing for the number of ounces. You can probably, without really thinking mathematically, you can probably figure out what the cost is going to be. It's going to be 49 cents times the number of ounces, right? To give you the final cost. And you'd be right. So the final cost is equal to 49 cents times n. That is my function rule, which you've probably already done before. Back when we did word problems in the first unit, we wrote equations. We were actually writing function rules. So you've already done this. Okay? Now we're going to use it. How much would a cup that weighs 8 ounces cost? Well, that 8 ounces is a number of ounces. This is an n value. And I'm going to plug that in for n. So what I'm saying is C of 8, right? When there's 8 ounces, what's the cost when I buy 8 ounces? It's 49 cents times 8. Just grab a calculator. I think it's 392, but I'm going to grab a calculator real quick just to make sure. It would be $3.92. How many ounces can you buy with $6? Now $6 could be your final cost. This is a C of n value. So let's say I can spend up to $6. I'm going to put 6 in for the final cost. And I'm looking for how many ounces I can buy. So I'm going to divide by 0.49. It's not going to be a good number. I get n equals 12.24, and it goes on further. Okay, so I can buy 12.24 ounces. Let's go to the nearest whole number. I can't round that up because if I go more than that, it's going to be more than $6. So I would say 12 ounces. Okay. Next one, to rent a hot air balloon, it costs $200 plus $21 per hour. Write a function rule to determine the final cost. Again, that's my final cost of renting a hot air balloon for h hours. So H is standing for number of hours. You do not have to do this on problems on the test or quiz or whatever I give you. I am defining them for you here. I'm telling you final cost is this, hours is this, but I'm just making sure you see that right now. Well, the final cost, the total cost, is going to equal $200 plus $21 per hour. $21 per hour. So there's my rule. Now I'm going to use it. I want to rent it for 6 hours. How much is it going to cost me? So I'm looking for the cost of 6 hours, right? So it's $200 plus $21 times 6. I get $326. How many hours could you rent the hot air balloon if you had $400? And you have to go to the nearest hour. So I have $400. I'm going to put it in. That's how much I could spend. Equals 200 plus 21H. Now we're just solving for H. Subtract 200. So I get 200 equals 21H. 200 divided by 21. I get H equals 9.52, which would tell me to round up to 10, but I can't round up because as soon as I round up, my cost goes up. So I can only have the hot air balloon for 9 hours. Last one. Write a function rule to determine the change you would get from a $20 bill when purchasing items that cost $1.25 each. Okay? So, I didn't define my variables here. So I'm going to do that now. I'm going to define my variables. I'll say C of X is my change, because that's what I'm looking for. Determine the change you would get when purchasing items that cost $1.25 each. So X is going to represent the number of items. Now, if you buy one item and you pay with a 20, what you're going to do is you're going to figure out the change, you're going to do 20 minus 125, and you would get $1 or $18.75 back. If I bought 2 items, that would be $2.50. To get the change from that, I would do 20 minus 250, which would be $17.50. But if I don't know the number of items, what I'm doing is I'm doing 20 minus however much the items cost. Well, how much did the items cost? 125 times the number of items. That right there is going to figure out or give me how much change I'm going to get. Okay? How much change do you receive when you purchase 5 items? So 5 goes in for X. How much change for 5 items? So 125 times 5, 625. 20 minus 625 is $13.75 change. Can you purchase 17 items with a $20 bill? And explain. So, again, different way of using your function rule. If I bought 17 items, how much would it cost? Okay, 125 times 17, I get 2125, which is negative 125. Can I get a negative amount of change? No. So basically what you're doing here, this 17 items would cost you $21.25. You can't pay with a $20 bill because it's not enough money. Okay? So can you buy 17 items? No, you can't. The explanation would be it costs more than $20. Okay? And that is writing function rules and using function rules. And that's the end of the unit.